Hello and welcome to Roid Rage, episode 57. I'm Jack Beyer, head of media here at AstroForge, and as always, we are joined by our CEO, Matt.
I like how you say "as always." I literally haven't been on this like the last 4 weeks, but yeah, as always.
You know what I mean. And we are also joined this week by one of our principal structures engineer, Sasha. Sasha, how are you doing?
I'm doing great.
Excellent. I like great.
Does anybody why do you ask this? I hate this. Why do you ask how are you doing? Nobody ever says shitty. They all say I'm doing great.
Ask me how I'm doing.
No, I don't care.
I was gonna say shitty. You jerk. All right, cool. Let's get right into it. I guess you spent decades at the Jet Propulsion Laboratory, and you've joined us here at AstroForge. So today we're going to dig into exactly what that transition's been like for you and what it's really like leading engineering at like a giant institution like JPL versus us, which we're like a 50-person company, scrappy startup, trying to get things done in a different way. But yeah, like just right off the top, give us like an overview of who you are and your career and
I guess please actually tell us the missions you worked on, Sasha. That's what I care about.
Yeah.
What did you work on at JPL?
So again, my name is Alexander Ermenko, but everybody knows me by my nickname, Sasha. At least if you ask at JPL who is Alexander Ermenko, everyone says, oh. But if you said, who is Sasha Ermenko, 99% of the people knows who I am. I came to JPL in 1997. I came to JPL actually to represent Russian company at that time. We have a joint proposals because at that time I was working for Russian aerospace company. And after that, I stayed for JPL for 29 years. And just relatively recently, in last December 2025, I retired from JPL. And almost immediately, after 2 weeks break, I started working for AstroForge. I started working at JPL in the system division, but very quickly moved to mechanical division. And most of my career stayed in mechanical division. And my roles were from support engineer, cognizant engineer, mechanical systems engineer, product delivery manager, chief engineer. That is the roles what I performed in mechanical division. As for the project what I worked on, projects which reached the flight, one of them I supposed to reach this phase. The project name is ROSA. It's Rosalind Franklin rover. It's a joint project with ESA, supposed to be launched in 2028. That was my last project that I worked at JPL. Before that, I worked on Mars sample return. What unfortunately do not ended up in the flight phase, but who knows what will happen. I hope one day we will see it happening. Before that, on Europa Clipper. Before that, on SMAP. Solar Moisture Active Passive project. That was second Earth orbiter JPL ever built. The first one was Explorer 1.
Whoa.
I didn't realize that. So they had that's because orbiting the Earth sucks. We all agree with that. But I didn't realize they only built 2.
Only 2, that's correct. We built a lot of instruments for the Earth orbiter satellites and the space station, but as orbiter, we built it only twice. Before that, I worked on Mars sample retrieval, Mars sample science mission, MSL, Curiosity rover. And before that, I worked on the instrument Aquarius. That was joint mission with Argentina. They provide the bus. NASA provide instrument. That was quite big instrument, 400 kilos. And before that, I worked on Mars explorations rovers, Curiosity and Spirit. And between all of them, with many proposals, formulations, and different type of technology development tasks. So that is what I did at JPL.
Okay, what's your favorite? Got to ask this question, right? What was the
question.
favorite project?
Europa Clipper. That would be my favorite one.
Just because it had an unlimited budget?
Believe it or not, that was one of the projects where the major challenge was not the budget, but resources in form of the engineers, because we were overbooked. We have in parallel 2 flagship missions going in parallel.
Which were what?
Mars,
Curiosity and
no, Perseverance.
Sorry,
Perseverance and Europa Clipper. Plus, on top of that, a couple of discovery missions and another stuff. and that was the time when JPL was at the max ever, including on-site contractors. I believe we were beyond 7,000 people.
Wow.
Whoa.
Yeah, it was quite big. But Europa Clipper, I will say that was my favorite one.
That's a good one to have as a favorite. I cannot wait till it gets to Europa and starts doing science. And personally, I'm biased because I saw it in the clean room. Of all of the different spacecraft that JPL has made since I've lived in California, that's the only time I got a clean room invite. So that's pretty cool. Also, I've taken photos of SMAP or SMAP.
SMAP.
I think it launched on one of the last Delta 2s, if I'm not
That's
mistaken.
correct. That's correct. We, for a long time, it was a challenge with SMAP. For a long time, when we didn't have assigned vehicle, and we have to be compatible with multiple potential launch vehicle, and Delta 2 was not on the list. But that in the end, NASA had agreement with Boeing that from the spare parts, they will assemble Delta 2 for us. And I have to say, Delta 2 was a real workhorse for, especially for the deep space explorations.
I sort of wish SLS was Delta Blue instead of orange. You know, the foam. The Delta Blue. Like, imagine SLS in your head right now, theater of the mind. Imagine a blue SLS.
I mean, literally, if I imagine anything other than SLS, it's better.
That's pretty good.
By the way, do you know that Europa Clipper originally supposed to be launched on SLS?
That's true. And then it was
Yes,
congressionally
absolutely.
mandated to
Exactly.
launch on SLS.
Absolutely.
Congressionally mandated. And
Exactly.
it took I forget
at least a couple of years. The baseline was that we even performed the first we call it zero couple lots analysis with SLS.
but
I'm not
basically
kidding.
there wouldn't have been
Wow.
a rocket for you, given all the commitments for Artemis and everything that needs to get launched. So there was never going to be a cargo SLS at a certain point, and then it had to get shifted over to Falcon Heavy.
Yep, and flight time to Jupiter will be cut from 6.5 years, what right now, to 2.5 years, if we will be on SLS.
Wow, it would have been that much faster.
Yes.
Why? Just because you had
Because
more.
it's direct flight and very high.
You just had more force
modules.
out of the rocket.
Mhm.
Yeah, I
Yep.
think the trajectory Clipper's taking as it is on Falcon Heavy, it does multiple gravity assists. There's like
Yes.
an Earth, a Venus.
Double EOS and fly by Mars.
Gotcha. Okay, where before it was just going to be direct shot.
Direct shot.
It's
Correct.
actually a really interesting trade that was done there because it's taking longer for the spacecraft to get where it's going. It's more expensive on the operations side, but it's way less expensive on the launch vehicle side because you're not fucking using SLS. So it ends up being more expensive on the ops side, but less expensive overall because no SLS.
I mean, Europa Clipper's a really cool mission to see, and I love when we do monumental feats like this. But let's be honest about it, right? It was a $6 billion spacecraft.
Slightly less, but yes.
Okay, I
Yes.
rounded up from 5.6 billion, whatever.
Yes.
It is that is too expensive to actually have us get good science long term. Like that's a one-time thing. We can't be at that price point.
I would love to see many spacecraft around every single planetary body in our solar system and then some. And I think flagship missions are really cool, and I think small bespoke missions are really cool. I think there's a place for both. That's me. But okay, so normally on the pod, at least lately, we've had a news segment. Do we even want to do news right now, or do we want to just go straight into the show? Because I feel like we're already.
I like
cooking.
how he asked us. Like he's the host, and he wants us.
No,
to dictate
I'm getting
program.
input. Do you want me to be a dictator?
Yes.
All right, we're doing news. All right, first news segment. First news segment. The NASA Ignition event occurred since the last time that we recorded. Gateway's now a moon base. No more near rectilinear halo orbit for Orion, but everything's going to low lunar orbit now. And Orion and HLS are probably, or at least rumored to be, docking in Leo for the translunar injection burn. So a lot of changes. There's also just, there's too much to cover in a single summary paragraph, but huge changes with the Ignition event. I just want to get both of your reads as longtime aficionados and workers in this industry. What was your read on the Ignition event? Because it made me feel like so damn good. It was like a breath of fresh air in an otherwise smoke-filled room to finally hear Administrator Isaacman just say the things that we all knew. It was just not
I
being
just have
said.
to say, from a media standpoint, it was run extremely well. From an event standpoint, it was extremely well, and it was the first time. I mean, it's probably the first time since 1997 that there was a NASA event that resonated with me, and I'll remember. Like everybody came out of that event, whether you're watching a live stream or there, with this renewed sense of energy and like something fucking cool is finally happening at NASA. I don't know if that'll be true. I think, look, whenever you have Jared obviously came out and gave a whole new pitch for what he wants to do and how he's changing a whole bunch of programs, and I think that's awesome. Now, what's actually going to happen once Congress gets involved? Who knows? And like it's, the administrator of these agencies isn't at the end of the day who decides the budget. Just like we were talking about with it being mandated by Congress on SLS, instead of like, it can be really hard to change those things as you go forward. But you got to admire that NASA is becoming relevant again in the minds of kids and in the minds of even adults, right? Like we all were inspired by that event, regardless what happens from it, and that someone fucking cares. There's just this sense overall that like NASA cares again. And I know all of the workers at NASA have cared for a long time. I didn't get the sense, honestly, since Dan Golden, I haven't felt like an administrator cared. That's changing.
Thank goodness. Thank goodness. Sasha, any thoughts on the Ignition event?
So everything what both of you said makes sense and good comments, but you miss another announcement that it will be a mission to Mars. So at the same time, they announced that it will be a nuclear-powered propulsion system.
Yeah, that's going to be called SR1, Space Reactor 1, I think.
They took our naming convention?
And that to me, especially because all my career I worked on the robotic space side. I worked a little bit on human exploration, but very little. That is another thing what really excited me, because we also start developing a good new pathfinder for the future explorations, both for the robotic missions and for the manned missions. And it goes slightly off from the mainstream to use more private industry for mainstream of exploration of the space, because it will be flagship missions, do we like it or not. But it's create a absolutely new kind of the capabilities for us for deep space exploration. So that particular also news was quite exciting, and especially for the people who are involved in robotic exploration, planetary exploration, and deep space exploration.
Yeah, I can't even believe I didn't include this in the news. I'm an abject failure for not doing that, because
Agree.
SR1 is so cool. So if you out there watching somehow don't know, it's going to be nuclear electric propulsion. I think it's using 4 Hall effect thrusters that are powered by an in-space fusion reactor, and it's going to go to Mars and drop off a number, I think 4 Ingenuity class helicopters.
I think it is up to 6.
Oh, wow.
The reason why I'm saying up to 6, they did not really specify the number. The video what they use, and people like me who knows the subject see that this video was not created for this particular mission. It was from our previous proposal, because it's showing cruise stage. For this vehicle, you don't need cruise stage.
Right.
But the entry vehicle, it's actually 1-to-1 from Mars sample return mission. But that could be very, very good kind of the technology demonstration mission. But it's also, again, my opinion, bring fresh blood into the planetary exploration and deep space explorations. That is also great news, my opinion.
Heck yeah. I'm really glad you brought that up. All right, next news item we have is Terrafab. Do we even want to hit Terrafab? I know I'm not supposed to ask you guys questions, but I don't know, man. The Ignition event, I put these in here for a reason. The Ignition event got me really hopeful and really excited. The Terrafab thing, I don't know quite how I feel about that. Matt, tell me how I should feel about Terrafab. Is it exciting to you at all?
We can pontificate about all these different methodologies here. I'll say this, really excited by the NASA event. We got a whole bunch out of it. We'll see what comes to fruition, what doesn't, right? And there's a whole bunch of detail. Us being in this community, I was really excited to see us reach beyond. And what I'll really point out, what Sasha said, is that these are new classes of technology. Terrafab is more an economical play, right? It's not necessarily a new class of technology. It's, can you build unit economics at scale? And I'm just like, I'm not saying it's wrong. I'm not saying it's bad or good. I really don't have an opinion on it, because I don't think about it. It's not, it doesn't inspire me in the way that a mission to Mars does or an interplanetary mission does. So I'll just say it this way, like, I only have so much brain power. It's not a lot. It's actually very low. And I didn't spend a lot of it being used on Terrafab.
When did you get the self-deprecation upgrade installed in your brain? It's pretty nice. It's enjoyable.
I just have to do this sometimes so I can relate to people.
Any thoughts on terrafab or mass drivers on the moon or anything like that?
Not actually. That is the area where I probably don't have enough expertise to have my own opinion, what could be shared with the public.
Fair
to be
enough.
honest.
All right, let's jump right into it. We talked a little bit about your background. So we talked about what missions you were on. What is a principal structures engineer actually?
Hold on. What the fuck? You have this news item in here that
Yeah.
you just skip over?
Yeah.
So you choose to talk about terrafab and not about this because this is the argument from the 60s between the Russians and the Americans. The Russians and the Americans about how to command spacecraft in space. And I'm going to sit here as an American and say, the Russians were fucking right.
Okay. All right. We're backing up. The third news item that I skipped over is SpaceX and NASA are rumored to be disagreeing on whether SpaceX is meeting the manual control requirement that is in the spec for the human landing system. Famously, Dragon is like mostly automated. They can hand fly it, but it's essentially a taxi from the ground to the ISS. Oh man, with deep space, the time delay is so long that you can't manually control things. So you have to have a spacecraft that can autonomously be controlled. So you're saying for something like the moon that the Russians were right, like because they went the autonomous
I just have
route?
never understood this. When we talk about Yuri Gagarin's flight, like he orbited the Earth, I think 3 times, and had 0 manual input. One time, whatever. Put no input in a spacecraft. He just sat there and was along for the ride. Because you know what? It's kind of really hard to manually fly something in space, number one. And number two, there's no need for it. We do these algorithms are very well understood and gone through. What is manual control going to do? In almost 99% of cases, just lower the reliability of the spacecraft. It doesn't mean there shouldn't be manual aborts. It's very different. And like when you saw Armstrong's flight, where he got tangled up and started going into a rotation, like having an abort there or a way to break a system, obviously something all people should think about. Why the Americans wanted to fly the capsules has never made sense to me. It's just we don't want to give up control. It's not based in logic. It's based in self-preservation that
It's an
astronaut can fly a spacecraft better than a spacecraft. And as an engineer, I just find this really hard to believe. And so what I'll say here is that SpaceX and NASA disagree. I don't think it's SpaceX and NASA disagree. I think it's SpaceX and astronauts disagreeing. And I stand true to this since day one. Like, if you can show me that an astronaut can land it better than an autonomous system, great. I just don't think that's the case. I would actually challenge if it's even possible to land as a non-autonomous system. I don't think it is.
That's a fair point. Do you have a rebuttal or perhaps a concurrence, Sasha?
I was born 6 days after Yuri Gagarin flight.
Wow.
One of the reasons why my name is not Yuri, because everybody at that time give their child who was born named Yuri, and my parents says, no, it's way too many of them.
We just had a guy on here named Yuri.
We did.
So-
we literally just did last week.
They named me very quickly different name. So I cannot really say that I was witnessing that, but I read about that. Also, the Russian company what I worked for, a lot of people who work at this company were from that period of time, and they have insights, and I have information from them. And they told me that it was, at the beginning, the philosophy was that because complexity is such a hard thing for control the spacecraft, but also there is no typical references. When pilot fly the airplane, it is Earth reference, it is something. In space, there is no such reference. Human cannot do, at least at that time they believe, and I totally see it why, that input provided by human will be probably not worth it. Any case needs to be done autonomously. On the top of that, you don't know how the human brain will be working in space at that time. So that was why they do it. It was actually also big opposition from military side because the first cosmonauts and first astronauts were pilots. And pilots said, oh, we're not the monkeys to be in a capsule and doing nothing. For that, put a monkey, not us. And that was a big opposition. Luckily, in Russia, it was enough force to say, you know what, guys, you do what you asked to do. And they said, just, yes, we will do it. And this is why the systems were designed to be completely autonomous. Is it the right approach? I strongly agreed with that statement.
I mean, they won.
So, by the way, history shows that sometimes if astronauts or cosmonauts would like to do what they would like, it will lead to the not a good outcome. We have examples.
Such as?
I don't like to speculate about that, but I read very interesting book that one of the American astronauts, and he has a little bit of the science background as well. When he was flying on one of the Mercuries, he trying to control the spacecraft in manual mode, and he spent so much fuel doing so that they have to cut the mission significantly in the length because there was not enough fuel left.
Yeah, that's no good. I'm very much like the astronaut should have control. I'm in that camp, but I understand where both of you are coming from, and complexity is a bad thing.
Why should they have control?
I will frame the answer in the way that I think about self-driving cars. Do I think self-driving cars should exist? Yes. Do I want a self-driving car so I don't have to drive myself during commutes? Absolutely. Do I also want a car with no steering wheel? Absolutely not. I want a car that if the car is messing up, I can take control. It's kind of like what you're saying, the aborts. Like, I want to be able to take control if it's necessary, but most of the time, I don't think it's necessary. So I think, we're mostly.
So you actually have a different thesis, which is you don't trust the system that would autonomously navigate the spacecraft. And so because of that, you want to have a backup that is a hand flight mode.
Basically, yeah. You never know, like, what happens if a micrometeoroid hits your star tracker or what have you. Now, to Sasha's point, the human inner ear is super imprecise. And, like, if you're in a car or in a bus or, you close your eyes for a second when you're not driving, obviously, and you try and think in your head, like, okay, we're going straight, we're turning left, we're turning right. Then you open your eyes and you see, oh, my inner ear was lying to me. So, without proper instrumentation, yeah, I'm sure you can get yourself in a really bad position as an astronaut if you're, just winging the joystick around or what have you.
But into defense of the people who believe that astronauts should have a control in an emergency situation, Apollo 13 will be a good example because during especially flying back, they do have to use manual inputs to survive and point it properly.
Right.
It doesn't mean that that is the way to do it. And if the system will be designed fully autonomously, maybe it will be also capable to do it because it was not designed this way. But it was a precedent in the past then in emergency situation, astronauts have to take over and that save it.
Right.
Yeah, Tom Hanks and Kevin Bacon did a great job.
They really did. Also, look at Starliner. I mean, when Butch was flying Starliner towards the ISS and they were starting to lose degrees of freedom, he took the controls and was like, "Oh, this is sluggish. This is feeling crappy." So there's also a little bit of like you can get.
But that's like such a false answer because that in order to draw that conclusion, you have to say that the engineering data on the ground did not already tell you that. But it absolutely did.
Okay, fair.
Like they've taken over, didn't provide any input except for now you have a human voice saying, "Oh, this sucks." Like we could have told you that. We didn't need a human input to do it.
Yeah, but the point is, adding ability to astronauts to control, it's not given to you for free. It significantly complicates the system.
It comes at a cost.
And that is where the trade is.
Yeah.
And that is why the Russians beat the Americans to space.
Real. All right. Now I'm glad we didn't skip that item. That was a good item to hit. Thank you. All right, Sasha, let's jump into your work at JPL and your work here at AstroForge. What does a principal structures engineer do day to day? Are you like modeling things on a computer? Are you physically putting parts together? Like, what does your life look like?
First, if you let me do it, I would like to correct.
Oh, please.
The name principal structural engineer is a wrong naming convention. My real sort of role is principal mechanical engineer, and now let me tell you what the difference is. Structures is only a small part of the mechanical subsystem domain. Even at JPL, when we have tons of the engineers, we never have principal structural engineers. When we provide the title principal engineer, in mechanical field, it could be mechanical systems engineer or manager, but not structural, because structural is very narrow field. And relative to my role, again, structures is just one of the part of the job what I'm doing. As example, mechanical engineering could include a lot of another disciplines. What is must be in mechanical engineering is overall spacecraft architecture, overall spacecraft configuration, accommodation of the components and instruments. It's just one of the examples. So if we will use this correction and say what is the role of the principal mechanical engineer, I think it is three, based on my experience, primary roles. Role number one, what is principal mechanical engineer doing in the early phases, pre-phase A formulations and phase A, and partially to phase B. The primary role is to develop a proper architecture of the subsystem and system. The role significantly changed after you pass preliminary design and go to the detailed design implementation. From that point of view, architecture baseline established. From that point of view, principal mechanical engineers start attacking the problems. Working with the teams first help to identify the problems and then attacking the problems. That is the primary functions of the principal mechanical engineer. And the third role, what very often escaped from attention, but mentoring. Mentoring the team is very important because I always said at any organizations which are developing a complex technologically and technically very, let's say, challenging products, team is number one. If you don't have team, regardless what type of equipment you have, regardless what of process we have, if you don't have a right team, you will be not able to achieve the success. Team is number one. In order to have a good team, you need to mentor the engineers. You need to create sort of continuity in the passing the knowledge, how to do it, because you cannot learn a lot of that type of things in the college. It's only on the job when you have dirty hands, developing the hardware, staying on the floor, testing it. That is the only way you can really gain the knowledge, and passing this knowledge properly to the next generation and helping them to do developing and delivering right product is very important. So this is why I'm saying the third key role of the mechanical principal engineer is mentoring.
That's fascinating.
Hold on. I think Sasha just tried to get paid 3 times as much.
It's a masterful gamut. But no, for real, I think about institutional knowledge a lot. That's a really interesting, third answer there. Institutional knowledge is one of those things that I feel like often goes by the wayside. Companies will, lay off a whole bunch of people, and then all of a sudden, the one guy that knew how to do a certain task is gone, and then you have no backfill. Like an example I think about a lot, believe it or not, is one of the few hull losses of a B-2 stealth bomber that we've ever had was because there was just some ingrained knowledge in the pilots of the B-2 that when they're taking off from Guam, they should turn on the pitot tube heater because some humidity can build up in the pitot tube. 2 pilots got deployed to Guam in a B-2, never were told that. It was never written down anywhere. And they go to take off. There's some humidity in the pitot tube. They get a conflicting airspeed indication. And the plane, if you ever see the video of it, there's video out there. It takes off and then immediately enters an extremely high angle of attack and does one of these, like a fugoid, and then bam, crashes into the ground, pilots eject, $2 billion gone because a little piece of institutional knowledge just got left by the wayside. It's incredibly important. That's a good call out. Okay, next question for you. At what point did you start thinking about leaving JPL? What planted that seed, if I may ask? Maybe it's not a fun topic.
No, it's actually perfectly good question. First, I would like to say that all my 29 years at JPL, I was very happy about the place where I'm working. I was very proud about JPL, about people who I'm working with. And even right now, I have only good memories about JPL in general. There is no ideal organization. It's always something what could be improved, but in general, to be at JPL for 29 years, it's a huge privilege on my side. why I started thinking about leaving JPL and why I left JPL. JPL was tuned for particular business model. NASA is our primary customer, and NASA provide to us the business. That is how JPL was originated and how it was. We have some non-NASA business at JPL, but NASA really restricted JPL how much non-JPL business we can have at JPL. By the way, JPLers as employees, we are not NASA employees. We're employees of the Caltech. It's a unique kind of the organizational approach. On the two centers, NASA centers has this approach. It's JPL and Applied Physics Lab, John Hopkins University. But all facilities, of course, everything is NASA. So we tuned that NASA provide to us business. And that was how the JPL worked for all of these years. But lately, NASA do not, in my opinion, provide us proper directions. And we ended up in a situation that it was no good projects for us, and it was no even proper signals from NASA where to go. And we ended up in a situation that we have a lot of good specialists, great lab, but no jobs. And when we tried to find a new job, first of all, it was resistance from NASA for us to be too flexible in this area. Lately, they start a little bit let us go to have ability to find jobs on the sides. But it was not easy for us as well because our business model was not tuned for that. And as a result, we were out of money and out of the interesting projects. And I found myself in a situation that I probably will have, 3 to 5 years before I should expect to finish my career. But it was no projects at JPL who I will see the product finalizing and deliver it in the end of this period of time. And also it was a lot of sort of activities which do not lead to the, my opinion, a proper interesting subjects in the end. I used to have ability to work on the interesting small projects, big projects, extremely large projects like flagship missions, but it was nothing like that available. And I will start thinking what else I can do in order to, in the end of my career, to see the results in the end. That was my goal is, do not just start the process. I would like to see the end result. And that led me immediately to idea that private industry actually a better choice from that point of view because the development cycle is significantly smaller, significantly faster, and that sort of led me to that situation that I found that working for the private industry will be probably a better way for me to finish my career.
Wow.
And then Sasha met me and was like, "Oh, I'm leaving tomorrow and I'll be there on Monday."
I mean, natural reaction to
Yeah,
getting it.
absolutely.
Okay. If Mars sample return had not sort of fizzled out the way that it did, do you think you would have stayed and continued working on that? Because it's a really cool mission, and I am personally incredibly sad that it's just sort of in limbo, not seemingly happening.
During my career, I worked for Mars sample return missions 4 times.
Oh my God.
Really?
Oh my God. 4
Yes.
that makes me mad that we don't have Mars samples already.
So, and each time when we start, we know that unless it will be enormous support, it will be not happen because by definition, Mars sample return mission is extremely complex and challenging task. When we start this time, the last time, and it started in 2018, I believe. Yeah, 2018 we started. It actually started on the best platform. We created a good foundation, establishing the key boundaries and constraints, which, in my opinion, potentially can lead to successful Mars sample return mission, such as we said it cannot be Class A mission because it will be way too expensive. We already know we cannot afford it. So, second, we have to bound appetite of the scientists. We cannot return way too much. It needs to be bounded from that perspective. And the third, we need to create a good collaboration because if we assign all of this money just for one institution like JPL, another centers will be hungry without any projects because NASA has a limited budget, do we like it or not these days. And we started properly. But then I think both NASA and JPL lost that kind of the key driving approach, and it started deviating left and right, which lead to redesign. We went to the phase B already, constantly changing the principal architecture of the mission. Actually, campaign, let's say campaign, because campaign includes multiple missions. We start working with, originally we start working with our international partner, with ESA. They will provide significant contribution. But then we also start leading them to the unknown territory, constantly changing requirements, objectives and everything. And that very quickly creating environments that we spending already a lot of money, we lost the focus, and that we don't have any really good target. And I also feel at the time that even NASA don't know exactly what they would like to do. And because of that, I already for quite a while have a sense that unless miracle will happen, this program needs to be really refocused. On my last position on Mars Sample Return mission was I was Deputy Project Chief Engineer on Mars Sample Retrieval Lander. I was exposed to all of this information, and I have more and more senses that we are not driving the ship into the right direction. We are not focusing. We are not going in a real path to make it successful because it was no clear vision how to do it, and of course, it's led to the very unsuccessful ending.
Why do you think that is, Sasha? Why do you think JPL lost its way on vision, or NASA lost its way on vision? What was the crux that made that happen?
Unfortunately, by signing the release papers from JPL, I am not allowed to criticize JPL. I cannot provide the answer. I will be happy to do it, but I cannot do it legally. Sorry about that.
No, it's fine.
I was trying to get you sued. Damn.
And to be clear, like I don't think any of us want to disparage JPL or NASA in any way. I think we're just all space fans, and we want to see samples get returned from Mars.
It's truly not about disparagement or even saying JPL is bad. JPL has just gone through this shift and multiple shifts, like all companies do in philosophy, right? I'm reading this book right now that talks about the first 5 Ranger missions that coincided with Mariner 1 and 2 at the same time.
Send me the title.
And it's just so interesting to see how JPL built 5. I mean, they were building 7 missions concurrently. They all had the same parts. There was a real discussion about whether they would take the solar panels off Mariner 1 and put them on Ranger 3 or whatever. I forget all the numbers here, right? But like the trades they were doing at the time were so interesting, and there's still this underlying tone of bureaucracy. And then when you hear about the Russian side and the Sputnik program and all the multiple Sputnik probes and what happened there, there's still a different level of bureaucracy, but it's like a military bureaucracy that, to your point, comes in and says, like, I said jump, you ask how high. It was just, it's different. That it's interesting that on these complex programs, no matter which you go, this bureaucracy always creeps in, no matter what side of the fence it's in. And it's a really interesting use case for us to study, to learn, is there a way to avoid it? And so far, I think everything shows us that there actually may not be. So do we instead accept it, and do we plan for it?
Yeah, that's a really good question. I would hope that there's a way to avoid it. I mean, certainly I think of things like SLS, where it's a sort of a congressionally mandated built rocket, and it has to use parts from all these different centers and everything. Like, you're just going to get a bureaucratic. Have you ever seen the movie Pentagon Wars?
That's the movie about the Bradley?
Yeah.
Yeah.
Yeah, it's like a Pentagon Wars situation where suddenly you have a bunch of different people who are stakeholders who all want to throw in their pet part of the project, and then you get...
Yeah, but has that ever been different? Is what I'm saying. Like, we like to pretend it is different in a lot of different ways. And what's news article number 2 we had is that NASA and SpaceX are arguing because there's 2 different stakeholders for Starship. And actually, there's more than 2 different stakeholders for Starship. Now, the state of Texas is a stakeholder for Starship. And as you actually look at this, what I'm saying is when products and projects start to take on orders of magnitude of dollars of GDP, there is multiple stakeholders in every single sense. And I actually just don't know if it's avoidable.
So the best you can hope to do is mitigate it and manage it properly.
I haven't thought that far. I don't know how to avoid it. Just don't. I guess don't be a certain percentage of GDP, and you don't have this problem, right? Stay small.
Yeah. All right. Well,
But I would like to say, MSR, Mars Sample Return, was killed not by technology. That is not the site which killed the mission or program.
yeah. That makes sense. I hope that at some point in the near future we can have a mission that goes out to Mars. And
I think it was killed by Skeletor.
I think you're right. That's me. That's me talking here.
Okay.
We have enough talent. We know what technology required, and we know how to mature these technologies in order to do it again. It was not in the technical side.
Dang. Well, the samples that Curiosity has left are there. Hopefully, we can pick them up someday. All right, so you went from JPL, one of the most storied institutions in engineering and spaceflight on the planet, to a scrappy asteroid mining startup with 50 employees. Walk us through that change for you. Like, was there culture shock? Is there still culture shock, maybe? Or are you're Sasha, you're a steely-eyed missile man, you roll with the punches and it doesn't matter?
First, again, it's public perception. Working for JPL, it doesn't mean that we constantly working on the high-end missions, Class A missions. During my career at JPL, I was working on the projects which last probably at most half a year to the projects which last 10 years and maybe even more. Depends from what the project and what you're working on. As example, on projects like Europa Clipper or Mars Science Laboratory, the maximum team size was never bigger than, let's say, 1,200 people. But JPL at that time was 6,500 people. So you can see that there's a lot of another business going on. But because of that, I have ability to see Class A mission, Class B mission, Class C, and even unclassified tasks. So going to the small businesses from that perspective was not something what I have not seen before. I also would like to say that even JPL was sort of in charge for these big missions. We have a lot of contractors, and some of these contractors were even bigger than JPL, like Lockheed Martin, for example. I work with Lockheed Martin, Denver on multiple missions. But we also have contractors which have like 10 people, 12 people. And I have, because they build the hardware for us or in other services, I work with them on a daily basis, so I know how this business are. And coming to AstroForge, it was not surprise to me to see how AstroForge is. So from that point of view, it was not a cultural shock for me. And I was prepared for that. I also worked on the different sides of the teams. At the peak, I left Europa Clipper project a couple of months after PDR, moving to the Mars Sample return mission, but I was product delivery manager for mechanical subsystem. And at that time, my mechanical team was already around 80 people. But sometimes I have only working on a project and I have only one person working with me or two or three. So, and the team was extremely small. Example, Aquarius project is instrument. I think our entire team was probably like 40 people, something like that. So I have experience with very different sizes of the teams and activities and how much responsibilities you have, how many hats you have to wear. And from that perspective, it was not a cultural shock for me. I was prepared to environments. Where is a big difference, and I think it's a key difference, is who is your sponsor, and because of that, working environments could be completely different. Working on the big projects, your primary sponsor is NASA. And as a primary sponsor, it's introduced to you all enchilada of the constraints, limitations, processes. Like working with NASA, it's mean you have to go through the gates. You have to go through the structural process of reviews. Sometimes budgetarian limitations introduce to you the schedule, and you know you can make this mission in 2 years. But in reality, you have to do it in 6 years because of the budget profile. So that is a difference. Here, and this is what I really like about companies like AstroForge, focus. you really can focus on the subject and you not have to go through the gates. That is, my opinion, drastically improve efficiency. It can help you in the schedule domain, really sort of be in environments that your key requirements are not fluctuating in time, and you know that the end product has much more focus kind of the targeting compared to what you're doing on the flagship missions. Because on some of the flagship missions, even in your phase B, but you still don't know in reality when you will be launched. So from that perspective, again, no cultural shock, and I like it right now for particular targeted missions better.
Awesome. I mean, I was going to ask next what the biggest difference in how engineering decisions get made. I think you kind of answered it. Like, there's way less gates and there's way more focus.
Again, depends from the size of the project. It also depends from the risk and complexity. At JPL, during the 29 years, I never designed the same spacecraft. All spacecrafts that I was involved look absolutely different, and it is a reason for that, because they always something new what never been done. That is speciality of the JPL. This is also why it's become very expensive, but they all required new technology, new approaches. That type of business required different type of oversight. Having periodical reviews and checking by the really expert committees is required, technical-wise. But it's also required really integrated team. As mechanical systems engineer, I have to be working in a very, very close kind of relations with the rest of the teams, with all subsystems, science part of the project. You wear a lot of different types of the hats. Some disciplines, like for example, if you're working on a big project and you're doing structural analysis, you're typically immune to that. You're just doing structural analysis. You just have to be a really good specialist in really narrow kind of the field. That is also part of the mechanical engineering, but it was not part of what I'm doing. As mechanical systems engineer, I always have to be wearing multiple hats all the time, because there is no any kind of the project which satisfied 100% requirements and desires from all disciplines. It's always compromises. And you have to keep orchestrating and helping orchestrating that with project manager and other managers to balance it between science, subsystems, control, development, budget, schedule, and everything like that.
Fantastic answer. Matt, how do you think about risk tolerance in regards to what we do here at AstroForge? Are we more accepting of risk? Are we less accepting
Then
of risk?
JPL?
Yes.
We don't have a choice. Like, the reality is what Sasha's talking about is when you launch a mission like Europa Clipper, 0 people expected Europa Clipper to fail and do expect Europa Clipper. That is a 100% success mission. And that is a big part as to why that mission costs $6 billion. I don't have $6 billion. So even if I wanted to accept no risk, we just have no shot on goal. So what is the real thing we're trying to do at AstroForge? It's like, how do we turn that risk dial? How far can we turn that risk dial to lower the cost? Because it's not, I don't believe it is a linear curve. I believe it is a J curve. And if we can be on the side where we maintain a low risk but don't increase the capital too much, it's where I want to be. So for us, it is all about staging out the risk at different parts and then being accepting of it. Like I've said before, if we launch the next spacecraft and we're all not terrified, we probably went too fucking slow. And like, that is the mindset we need to be in, because speed is what matters at a startup, and our success is not guaranteed. We have to earn it, and we earn that through launching and trying and figuring out what went wrong and iterating till we run out of money.
Heck yeah. I mean, I'm here for it. I've said it over and over again. Like, human lifespan is only so long. I don't want to wait 10 years, 20 years for asteroid mining to be a thing. Let's make it a thing.
Brian Johnson's trying to fix that, and I'm on this program. I don't know if I'm going to do the whole, like, do DMT or whatever he did to hallucinate, but I think we can live forever.
We'll save that for another episode. Sasha, how do you think about risk differently working here at AstroForge or working at JPL? Has there have to be a recalibration or anything, or is it just the same?
As I said, JPL also have a very huge variety of the type of the business that we performed, and in some areas you have to be really uh, on the position that you need to accept risk. In some areas, you cannot accept high risk, and you have to act accordingly. What I see specifically for AstroForge in the risk domain, it's also different from, let's say, flagship missions. We cannot afford to develop new complex technologies except mining process. Mining process is never done before. You have to do it. But as a delivery bus, we have to rely as maximum as possible for proven technologies, proven processes. That is, to me, how you will manage the risk also. That is the approach. Minimize the areas where you have to develop something new, because developing something new is always additional risk, additional money, additional schedule, and stuff like that. That is, to me, is how at least to my view, how we can make AstroForge successful. Try to minimize new developments as maximum as possible off-the-shelf solutions, proven solutions.
Yeah, it's a really good point. The best way to minimize risk is to just not have it. So remove everything that introduces risk, and we constantly have discussions about how to make the spacecraft as simple as possible. That's it.
I love it. I love it. It just makes sense. It's like a no-brainer. Is there anything from the JPL way of doing things that you've brought over to AstroForge and sort of shaken things up? And conversely, is there anything from JPL that you're glad to leave behind?
Working for very complex Class A, Class B missions, it's and of course working for NASA, it's required a lot of specific. You have to follow a lot of specific processes. Amount of the process what you have to follow is enormous. I understand why it is, but at the same time, that is a huge tax on what you're doing. Leaving behind all of that and do not have real requirements to follow all of these processes, that is a huge relief to me. I understand why we have them at JPL. I understand why we need to have them. And I'm very happy that here we can create environments which will not require that many constraints, processes, and stuff like that. That is, to me, is huge relief for me, and this is what I left behind working for AstroForge. If you'll be working for another company which has similar kind of the complexity of the missions like JPL, any case, you have to be involved in that. Another, what I like, even I respect NASA and everything, working for NASA introduced, again, a lot of another constraints. And working for the company which doesn't have sponsor in form of the NASA, relieve all of these constraints behind. That is another area what I'm pretty happy do not have. What I bring to AstroForge, I think it's experience of being on the top level of technological development, complex missions development, and from the complex missions to the very simple ones, and everything in between, and involvement from the early formulations, from idea to delivering the hardware, testing, and launching. That experience across all of the phases, I think this is what I'm delivering here, an ability to see where potential problem or risk can pop up based on my experience. That is one of the key, I think, abilities what I bring and knowledge what I bring to AstroForge. Another thing is, as I already mentioned, mentoring. That is one of the tasks what I can see in front of me and what I'm already doing. Try to pass all of these knowledges, approaches to the young engineers that they will grow up as fast as possible. Because college will never provide you ability to be immediately great engineer. And pass an experience, you can read the books, you can see like documents, but nothing can replace working with engineer who has experience in front of you. That happened to me. I grabbed a lot of experience from the more senior engineers at Russian company, then at JPL. And one of the things what I also would like to say, if you would like to be a good engineer, you should never stop improving your knowledge as well. And that is something what one of the still challenges for me at AstroForge that I don't like to stop it. I still would like to progress and see where I can learn something new. And I already see capabilities in different kind of the fields relative to that. But that is what I bring to from JPL to and my Russian experience to AstroForge.
I love that. I like being able to help young engineers grow up as fast as possible. That's noble. That's like I applaud that. That's really cool.
Forget all the noble stuff, though. I think what's really important to recognize is there's not a lot of people like Sasha that work at big companies. What is very different that I will tell you in engineers that come out of large institutions is that they love to work within constraints. And sometimes it is very difficult for engineers that are very constraint based to come work with no constraints. It can be very freeing. It can also be very scary. If there's nobody here to tell you what to work on or what to do. The problem is, can we get to an asteroid on the next mission? Go. And if you can't pave your own road or understand how to go look at that, people get lost. And that's a really hard thing to do at a startup. That's the kind of niche that is very difficult for us to pull out of large companies, and why, as a general rule, like, we don't hire a lot of people out of JPL or out of Boeing. We would love that intuition. That intuition is invaluable. When you go into a trade study and Sasha can just look at us and be like, hey, idiots, like, all of these ideas are stupid. Go study these two. You just saved us weeks and weeks in time.
Yeah.
But to be able to work in that non-constraint based environment is very difficult for people that have always done it before.
Yeah, I just would like to echo what Matt said. That is also my experience at JPL. We have a lot of the world-class specialists, but they are so narrow field specialists. And if they go in somewhere else, they don't like to expand beyond because they tune for that and they don't like to change it. One of my opinion, again, what helped me to be useful at AstroForge, that I'm not that narrow field specialist. I'm a system guy. And that allowed me to more easily adapt to a situation when you have to wear multiple hats. And another also ability, what we grew for some engineers at JPL, we call them cognizant engineers. You are responsible for delivering the widget, hardware, software, whatever. You are in charge for delivery. The rest is your own problem, how to do it. Not many companies have that kind of attitude, and they said, oh, you're doing this, you're doing this. They constrain you what you're doing, but you're not focusing that I have to deliver. You're focusing, I have to live in certain constraints. That is what I also trying to teach engineers at AstroForge. Do not follow, oh, I've been asked to do that, I will do that. No, be in charge of your delivery. That is what is key for you. Of course, you have to follow the orders, but your mentality should be, if I'm developing this piece of the hardware, that is what my end goal is, and I have to plan accordingly. And I know if it required interfacing with another disciplines or anything like that, or the schedule or resources could be limited, it's my responsibility to start actively and proactively working on these environments and try to establish that my delivery will be successful in the end.
Fantastic. All right, let's nerd out a little bit on the actual mechanical engineering work. What's unique or especially challenging about building spacecraft that like we're trying to? Is it the fact that we are trying to take so many off-the-shelf components and keep it simple? Like what is a challenge that with our approach?
So grabbing off-the-shelf components is not a big challenge. Grabbing the right components, which will be right for your system, and create a proper system, which will be, first of all, affordable, executable, that you can build it, that you can test it, and then all of that will be within the budget and schedule what you have. That, to me, is the key challenge. It's not unique for AstroForge, but it's a little bit amplified at AstroForge because, again, our goal is to build as maximum robust design within the constraints of the budget, schedule, and risk. That is where, my opinion, the balance is the biggest challenge, and this is what we need to focus on. Buying from the site it's not really concerning me because it's just changing your slightly risk approach. Of course, if I would like to have Class A parts, it will be great. Is this absolutely necessary? Probably not.
I hope not.
But again, you also at the same time need to recognize you cannot fight the physics. And system need to be robust enough to perform as you expected relatively complex mission. You try to minimize complexity of the mission as maximum as you can, but at the same time, the mission will be still complex. Space is not forgiven. And the missions like going to asteroid, land on asteroid, and mine asteroid, and then coming back, it's not that trivial. And we need to keep that in mind and trying to develop a system which will, if possible, to maximum decoupled these functions, that you can test them separately. Because if everything will be coupled to maximum, it will be impossible to test, it will be impossible to develop. So, as I said, simplification, decoupling, clear understanding where the challenges are, and focus where the challenges are, and try to have off-the-shelf solutions which will minimize your risk and challenges. It's a recipe to have successful mission.
And do it for like 1,000 times less money.
That's the idea. I love it. How do you approach designing for scenarios or environments that have very little heritage data? Like, we're trying to mine an asteroid. We're trying to land on an asteroid. It's only happened, what, 2-3 times? Like, how do you even wrap your head around that?
As I said, the key is try to make different compartments. What is actually was done before, and what is absolutely new, what needs to be discovered. Mission to asteroid has a lot of elements and phases what could be based on existing technologies, existing approaches. Launching on a launch vehicle, it's not different. Flying spacecraft to the asteroid, it's more or less done before. Landing on asteroid, mining, that is a different thing. So that is what you need to be focused on. So again, keeping the balance and focus what is new, and understanding that that is where your focus should be in development. But existing technologies, just use them properly. That to me is where the specifics what we have. And do not overestimate like how simple it will be to land on asteroid if you don't know how to do it, or mine an asteroid, because nobody done it before. At least it was several missions who touched asteroid and go or landed on a comet. I cannot say that all of them were successful, but at least it was something in this area. Nobody yet mined asteroid. And to me, that is, if I will say, the maximum challenge at what we're doing, that it is. And I think that currently at the company, at least from my perspective, from engineering point of view, we have a proper balance that we dedicated significant resource to address what has never been done before.
All right. Well, we're going to have to do a part 2 with you, Sasha, because this has been really great, and we have like a whole other segment to do. This has been awesome. Thank you so much for taking your time to come talk to us, and I think we're going to have you back on the pod pretty soon if you don't hate us now. Well, me.
No problem. We'll be happy to do it.
Awesome. All right. Well, let's wrap it up. We'll save this mailbag question for the next episode. Thank you all for watching. If you have any questions, throw them to mailbag@astroforge.com or throw them in the comments, and we will answer your questions on a future episode. And on that note, we'll see you on the next one.